Okay, so number one, we're raising to the second power. So everything inside the parentheses is raised to the second power. So 3 to the second, x to the 6, y to the negative 4, over 4 to the second, y to the 8, z to the negative 10. Okay, is that what everybody's got so far? Okay. So the next 3 to the second is 9, x to the 6. Now since my y has a negative 4 power, I'm going to move it to the bottom and make it positive. So y to the positive 4 on bottom. Then I have 4 squared, which is 16, y to the 8, z to the negative 10. So since this 10 is negative, I'm going to move that up to the top and make it positive. So z to the positive 10. Okay? So then we're going to combine from there. Can I simplify the 9 over 16? No. So we're going to leave 9, 16, x6, z10. And then you can put the y's together. So y to the 4th and y to the 8th will be what? Okay, y to the 12th. There's a final answer. So number 2. We're doing a 4th root. So we need to break down our numbers as much as we can. So the 81, 9 times 9. The 9's break down into 3 times 3, 3 times 3. So it's the 4th root. Don't forget the 4th root part of 3 times 3 times 3 times 3. X to the 40th. Y. Now I'm going to split up my y to the 9th to make it y to the 8th, and then another y. And then the z to the 4,000 with an extra z. So now we're looking for groups of 4. So I have one group of 4 3s, so we get a 3 on the outside. How many groups of x's, 4 x's, can I get? 10. I can get 10 groups of 4 x's, so that goes on the outside. Do I have any left over? Nope. How about the y to the 8th? How many groups? I can get 2 groups of y. And then I do have a y left over, this extra y right there. So that's going to go under the radical. Make sure it's a 4th root. Okay, don't forget that 4 right there. Z to the 4,000 would be z to the what? With an extra z underneath. So this is your answer. And the last one. Now, because my exponent is negative, I usually like to make that outside exponent positive. So I'm going to take the fraction here and flip it. Okay? So x squared, y to the negative 3z over x to the 3rd, z to the negative 2, y raised to the 3rd power. Okay, so now we're going to raise everything to that 3rd power. So we have x to the 6, y to the negative 9, z to the 3 over x to the 9, z to the negative 6, y to the 3. I raised everything to the 3rd power. I have a couple of variables that have negative exponents on them, so I'm going to flip those around. X to the 6, y to the 9, z to the 3, and then on bottom, x to the 9, my z goes to the top, and y to the 3. And then we're going to combine. So we have to combine our x's. X to the 3 on bottom, y to the 9 and y to the 3rd, y to the 12, and then on top, the z's, z to the 9. So I want to do a little more work with the converting your rational exponents into radicals. So I have the rule up here on top. X raised to the a over b power is the same as the bth root. Okay, so b root x to the a power. So when we're doing these rewrites, so from exponent to radical form, you're going to use this rule. I will only accept the 5th root of x to the 3rd power. Okay, so the exponent has to go inside. Okay, so the bottom number here is your root, and then the top number is the exponent. Okay? Works the same if you have a radical and you need to convert it to a rational exponent. The root is going to be the denominator. Okay? And the exponent is going to be the numerator. Okay, just like above. So then you would rewrite that x to the 3/4 power. All right, try these practice ones. So since these are just rewrites, we're wanting to use the appropriate rules in rewriting the expressions. So if we're rewriting from a rational to a radical form, it's going to be the 9th root of x to the 5th. So the exponent goes inside. I will not accept the other one for the rewrite. Okay, we only use the other one when we're simplifying numbers. And it makes it easier to do the roots and the exponents. Here, we want to do it this way. So number 2, it's the 7th root of z to the 4th. Okay, number 3, 4th root of y to the 13th. Okay, we're just rewriting. We're not simplifying or anything like that. Just rewrite what it means. On the bottom one, y to the 7/3 power is the same as the 3rd root of y to the 7th. Number 5, x to the 5/6 power, and z to the 10/4 power. Let's do this one. We'll do these 3, and then it'll be the practice test. Let's go ahead and work through some of these. I think the first one will go pretty quick, and you were all probably pretty consistent with that one. The second one seems to be where most people are still working or almost done. And then we'll go over the third one a little bit as well real quick. And then I'll give you the practice quiz to work on, which is some of the same stuff. All right, first one. I changed it to a cube root, so we're looking for groups of 3. So if we break down the 32, it's a cube root. That's 2 times 2 times 2 times 2 times 2. Okay, 5 2's. When you multiply them together equals 32. X to the 8th, y to the 3rd, z to the 12th. So again, we're looking for groups of 3. So I have one group of 3 2's. So there's a 2 on the outside. I have 2 left over. So that means I have a 4 on the inside. You have to multiply them back together. Now we're looking at the x to the 8th power. How many groups of 3 x's can I get out of that? I can get out 2 groups. So x to the 2nd with how many left over? 2 left over. So let's look at that real quick. X to the 8 is 1, 2, 3, 4, 5, 6, 7, 8 x's. Groups of 3, there's one group. There's another group with 2 left over. So 2 groups. Outside are the groups. Inside are the individual ones that are left. All right, y to the 3rd. How many groups of 3 y's can I get? One group, because it's y times y times y. There's my 3 y's. So one group of y's on the outside. How about z to the 12th? How many groups of z? 4. So z to the 4th on the outside. That's your answer. When I look at this problem, what I notice is I have one group raised to a negative exponent. I'm going to move that first so that it's positive. So on top, 120, x squared, y to the 5th to the 2nd power. On the bottom, 2x4, y3, z all raised to the 2nd. 3y to the negative 2, z to the 3 raised to the positive 3 power. Moving it only affects the exponent on the outside of those parentheses. Okay? So then it's a positive 3 exponent there. Now I'm going to go ahead and get rid of the parentheses. All of my outside exponents are positive, so now I'm going to get rid of those parentheses by raising everything inside to that power. So I have this set raised to the 2nd power. I have this set raised to the 2nd power. And then we have this set raised to the third power. Okay, so I'm going to do that next. So you have the 120, x to the 4, y to the 10, 2 to the second, x to the 8, y to the 6, z to the 2, and then we'll do the other one, 3 to the third, y to the negative 6, z to the 9. Okay. Some of the things I'm going to do next, I have this negative exponent, so I'm going to put it on top so I can make it positive. That's the only negative left. And then I'm also going to simplify my numbers, okay, by just taking them to the power, 2 to the second and 3 to the third. So on top, 120, x4, y10, y6, because I moved that negative up. And then I have 4 times, what's 3 to the third? 27. Then x8, y6, z2, z9. Now we're going to do some simplifying. Notice I did not multiply the 4 and the 27. Why might I have not done that? 120 divided by 4. Okay, how many times does 4 go into 120? 30. Can I do any other number simplifying? Well, look at the numbers I have left. I have a 27 on the bottom. I have a 30 on the top. Can I divide them by anything? I can divide them both by 3. So divide this by 3, we get 9. Divide that by 3, we get 10. Okay, so we simplified our numbers. Also, what happens here? Y to the 6 over y to the 6 is what? And y to the 0 is 1. Okay, so that equals 1 right there. So I have a 10 on top, 9 on bottom. What about my x's? That x and this x. X to the 4 where? X to the 4 on the bottom. I have a y10 left on top. Put the z's together. Z to the 11 on bottom. That's your answer. All right, so then the last one with our rational exponent. So remember, when your exponents are fractions, you need to simplify the inside part first. Okay, then it makes working with that fraction a little more manageable. So look at my numbers. Can I simplify the fraction 9 over 72? So 1 on top, 8 on bottom. So an 8 on bottom, 1 on top. I have some negative exponents there, so I'm going to move some around. So I have x to the 8, y to the 7 on bottom. So this negative exponent I moved to the bottom, so it's positive. I have a z on top. I have this negative exponent, x to the negative 4th on bottom. I'm going to move it to the top. Y to the 2nd, z to the 7th. All right, so then we'll do some combining on the inside. So the x's can go together, my y's can go together, and then I have a z on top and bottom. So what do I do with my exponents when it's on top and bottom? Yeah, you subtract the exponents there. So on top, x to the 12, 8 on bottom, y to the 9, z to the 6, to the 2/3 power. Did I lose? Oh, no, my number's still there. Okay, good. Now everything to the 2/3 power. 12 to the 2/3 power, 8 to the 2/3, y9 to the 2/3, z6 to the 2/3. So what would my exponent be up here on top for the x? X to the 8. Okay, if you look at 12 times 2/3, 3 goes into 12 4 times. 4 times 2, that's where the 8 comes from. Okay, on the bottom, I'll work with this 8 and 2/3 in a second. What would my exponent be on the y? 6. Okay, 3 goes into 9 3 times. 3 times 2. Okay, so 3 goes into 9 3 times. 3 times 2 is 6. My exponent on the z. 4. Okay. 3 goes into the 6 twice. 2 times 2 is 4. Now let's look at this 8 to the 2/3. That would be the cube root of 8 raised to the 2nd power. What's the cube root of 8? So 2 to the 2nd is 4. So a 4 on the bottom. This is our final answer.